I help our clients deliver better quality faster. Here's a brief list of the clients that we help. One of the things that we're most proud of, one of the metrics here, is this 1.6 billion collective users use the apps that our clients develop, and then we test for those clients. Okay, great. I hear you can hear me. Awesome, thank you. Also, for Testlio, we make this magic happen with the Testlio network. We have over 10,000 engineers or software testers across the world, and they are really strong testers. We have a very high bar for the testers that we accept into our network. Only about 3% of those that apply are actually accepted. And these testers are working together in a burstable team that will bring 10 to 50 testers onto a project in order to get it tested in a very quick manner and get that feedback back to our clients. And the testers are compensated by the hour, which means they're not competing with each other to be the first person to submit a bug. So they're working together and collaborating. So let's talk about testing. But before I do, let's talk about a story. Excuse my voice. I don't know why it started to crack now. But I want you to imagine a army, and an army has a mission. They have to go from here over, maybe take that hill over yonder. And in between where they are and that hill, their objective is a minefield. Now, I didn't want to use a picture of a real minefield, so I'm using Minesweeper. And what this army does is they'll send out 1 or 2 brave individuals who will go into that minefield and poke and prod. And what they'll do is they will find a safe path through the minefield. And they'll mark where the bombs are. And then what happens is once they've cleared a path all the way through, then everybody else in the army follows the same steps that are safe to walk through. Now, you can probably guess this analogy is automating tests. So our brave individuals in our analogy are the automation engineers who will implement the steps of a workflow for an automated test. And what they'll do is, the metaphor here is they'll code the steps to go from one side to the other, or to complete a workflow in your product. Let's say it's a checkout workflow. So they will implement those steps until that workflow is successful. Now, they may run into a few bombs, which are bugs in this metaphor, and hopefully they don't just mark them, but they actually get those bugs fixed. But once they find that safe path to make the checkout work, then they have a good automated test. And so then that automated test is run over and over and over again, following the same steps, using the same data. So you're basically running through the same path over and over again. And what this picture shows is there's still many other bugs in the product that our automated test is not finding because it already found its safe path through the maze. So how do we deal with this? Well, we use creativity and we do exploratory testing and we look beyond the safe path. And that's where humans come into play. So the automated tests take predictable paths, and humans are the ones who brave the unknown. Let's talk about testing a mobile app. As we all know, testing a mobile app, there's an entire architecture behind it. It's not just the mobile app itself. So you have all of these different services behind. There's login, profile management, there's analytics to kind of track what the customer is doing. I'm going to be talking about an example app that's streaming. So there's a content management system and a content delivery network behind this app. So when we're talking about testing the mobile app, we're talking about testing this entire architecture. Another big part about the architecture, especially for mobile apps, is we're no longer just talking about iOS and Android. Our customers and us as users, when we think about a mobile app, we want to test that app wherever we are connected to the internet. So it might be we're on a browser and we want to use the app through the browser, iOS and Android. But with the streaming app that we're going to talk about, really has to be everywhere. So it's on the streaming devices, it's on the gaming consoles, and all the other platforms. So when we think about an app, the user may think about it as one app, but from a technology perspective, it's very diverse. Alrighty, let's start talking about testing strategy. So one of the first things I do when I come up with a testing strategy is I ask, how fast do we need to go? What's our release cadence? And one of the things that we've done at Testlio is we have studied our client base plus the broader market, and we found that 65% of mobile apps are released at least on a monthly basis, at least once per month. 26% of them are once or twice a month, which means they're kind of on that 2 to 3 week cadence. And then 15% of them are released weekly. So, and as we all know, that trend is moving towards faster and faster release cadences. So we have a whole lot of testing to get done, but not a whole lot of time to do it. So we need to think about how to tackle that. Next thing about the testing strategy is which testing practices should I apply? You know, should we do more unit testing? Should we do UI testing, exploratory testing, all kinds of different tests? And yes, we do. One of the things we'll have to do is make a very logical decision about which type of tests that we implement in any single point in time. So, for example, if we have a 2-week release cadence, we're going to want to think about what's changing in this release. Are we making some back-end services changes and maybe restructuring things? So maybe we should do more load and performance testing. Or, you know, are we just adding some features? Or are we going to a new country where then we need to get some localization? So it's very context dependent on what types of testing we want to implement. One funny thing, I just used a word cloud generator to make this slide, and I copied over a list of testing types, and look where it decided to put fault injection. It put fault injection kind of going up like it's actually injecting a fault. That's purely by accident, and I loved it. Okay, so the testing strategy requires a very comprehensive strategy. So we need to test at multiple levels. This is where I could have put in the testing pyramid, which I think most of every presentations or a lot of presentations are sharing that pyramid. But we need to think about unit and API tests. We can leverage the speed and reliability of those tests and complement them with other tests that thoroughly test the full stack. So unit and API tests, very quick, very thorough, but they're not comprehensive. So we need to have multiple levels of our testing strategy. We talked about all the testing types. So in any one iteration, we may have different types of testing that we need to do. Now, we only have a couple of weeks to do this, so that's why we're all doing continuous testing. No longer do we have the days where we would develop a bunch of code, which would cause our quality to drop, and then we would spend time testing and fixing and bring the quality back up. Now we have to keep that quality at a constant at all times. So that's where continuous testing comes into play. And then lastly, we need to leverage the power of the machines to have the speed and reliability, and coupled with the creativity and exploratory nature of humans. So in the minefield example, it's great that we have a test, an automated test that can go through that workflow. And what's great about that is we'll test that 20, 30, 40 times a day to make sure that that workflow is still possible. Just because a test isn't finding bugs, that doesn't mean it's not a valuable test. It's still very valuable. It tells you, hey, the checkout workflow still works after I made these changes. So definitely there's a great value in running those tests. But to really find the bugs and the human experience, you need to bring in people. Oh, all right, let's talk about a use case. So I want to talk about the CW. And the CW is a television network that has some great shows you can see here on the right. Testlio and the CW, we've been working together since 2016 to help them with their testing. And I'll give you some examples of some of the tests in the next few slides. The CW, they're pioneers of ad-supported, free-to-watch shows. So they put their shows out there, and they monetize with advertising. But also, it's more about that principle of we as consumers, we want to watch these shows wherever we're connected to the internet, whether it's on the TV or a mobile device. And that's why those apps are available everywhere. Now, that's hard to do because it's a very different set of technologies. All righty, so I want to walk through 3 scenarios. First is, which episodes do we present to the user in the user interface? Next is, let's track the user behavior so we can learn. And then let's actually watch an episode. So the CW, if you click into a show, and I chose Nancy Drew here because I used to read the books to my daughters, and the CW has updated those stories from the 40s and brought them up to date to the 2020s. And Nancy Drew has grown up as well. But you can see here in the screenshot that there are 18 episodes available. And so the app displayed to me 18 episodes. But now, how did that actually work? Well, if you remember, there's going to be a service on the back end, and I'm guessing there's a function there or a method called episodes to present that's going to return me a list or return a list to the mobile app of which episodes they should list for the user. And there may be some parameters like the geolocation. So in the United States alone, there are 432 different MSAs, or metropolitan statistical areas, big word, which then are assembled into, I think, about 27 major markets for television broadcasters. So there's a geolocation component with the episodes that get presented. There's a content management system. So the Nancy Drew, this is the first season. There are only 18 episodes available, but some of the other shows on the CW network have been around for maybe 10 years. So they have 10 seasons of, 20 episodes per season, so roughly 200 episodes. So the next factor is a policy. And this is where the team, the decision makers at the CW, will make a decision. Okay, what episodes do we want to show based on policy? So there may be some licensing agreement, which are going to be heavily factored into the content and the geolocation, and there may be some promotions. As we know, there's a lot of streaming services nowadays. They're opening up their libraries for more episodes while people are sheltering in place at home. So there may be some promotional or temporary ideas. So how would I test this? I would test this, excuse me. I would test this function by starting off with an automated unit test. And the automated unit test is going to be able to manage this entire complexity. And again, it's testing the algorithm that determines which episodes to present, given these 3 inputs. So there's many thousands of permutations that are possible that aren't going to be very practical to test manually. But we can thoroughly test this algorithm by using mock data and really thoroughly testing it. Using an automated unit test. we can test all 432 geolocations. We can even make up geolocations that don't exist and make sure that the function handles that properly. But we want to also confirm. So we trust the automated test. That gives us some freedom when it comes to manual testing. Manual testing may be just sampling, spot checking a few cities to make sure that the results are correct as presented to the end user in the mobile app in that city. So we can double check the result with a smaller set of actual people. Let's talk about analytics. So, companies like the CW and basically every mobile company, they track user analytics, which means they want to track what the users are doing with the app. And that allows us to learn and build a better experience, a better product for those users. So we find out what they like, what they don't like, what they're having difficulty with. And so the analytics portion, it takes a user takes an action in the app, and then that eventually translates into a dashboard where some analysts can get the insights on what the customers are doing. But in order to make that happen, there's a lot of data recorded. And this is literally just 2 actions in an app, and about 50 milliseconds worth of usage. And you can see there's a lot of data here, and it would be very tedious for a person to go through and validate that all of this data is correct and it's correctly formatted. So this is where I would try to look at having an automated test that injects the UI actions through a UI-driven framework, and then an API test which sniffs the analytics traffic and then does the validation. So you're doing both automated on the UI and then the API to validate. And what the API test can then do is validate that all of this data is correct. If a person tried to do it, it would be very tedious and error-prone. But often we also have to fall back to a semi-automated test. If you remember when I mentioned all of the different platforms, we can generally write one test that covers both iOS and Android together. And we can write one test that does all of the browsers together. But then when we bring in the other streaming sticks like Roku's and gaming consoles like Xbox and PlayStation, those are all different technologies. So that's a lot of investment for automated tests. So this is where we may want to scale up with a bunch of people or a few people to do a semi-automated test where the humans will take the action in the app, maybe on the Xbox, and then use the API test to do the validation. And then sometimes there's even a brand new feature that may come in, and we haven't had time to automate that test yet. So that's where we may do a human-based test completely because the humans are adaptable. Alrighty, let's move on to actually watching an episode. So this is a screenshot from the Nancy Drew show. This is actually the first few seconds of the show. And a young woman is looking down this cliff into the water. And spoiler alert, doesn't end up well for that girl. So sorry to hear that. But anyway, when we think about testing the video player here, we can actually do some automated UI tests, and we do. And we can test a basic functionality. We can click the play button and make sure that it converts to a pause button. We can capture some frames and make sure that the frames are changing. That tells us that the video is actually playing. And, we can do this kind of basic test. And that's very good for running on an everyday, multiple times a day basis, because that will give you a very gross feeling if the video player broke. But there are some limitations with automating tests here. One is they generally run on simulated devices. And if you've done video player testing, many of those issues are device dependent. So it's good to have humans come into play with real live devices And the humans will be able to give you a judgment on the video quality. Does it look good? Is it responsive? So when you hit the pause button, does it actually pause? And when you hit play, does it play? They'll be able to explore and find issues. They'll be able to turn the device orientation around. I know you can do that on simulators, but having a real human do that adds a whole lot more in terms of the responsiveness of that behavior. What happens when you receive a phone call while you're watching a video? Does the video automatically pause? All kinds of stuff. If I mention, when we bring testers in for Testlio, they all have their own devices. So you get this experience with real live devices. Alrighty, let's talk a little bit about automated tests versus human-based tests. I know it's a very common topic. So with automated tests, we get fast feedback. We can run thousands of tests in parallel. And this is especially possible with Sauce Labs because you can spin up many, many VMs and test across the Selenium grid. And you can really reduce the time it takes to get automated test results by using the large-scale parallelization possible. And I think that was my 10-minute warning. Repeatable, as we mentioned, you can create the same test and have it repeat over and over and over and over again. And the automated tests can run off of a trigger, so they're available 24/7. So let's talk about some downsides. There is an ongoing investment required to build new tests when you have new functionality and maintain the existing tests. So if we want to add a new feature, before it could really be tested with automation, you also need to write an automated program, which is called an automated test. And then flaky tests are kind of a problem with automated tests. So you need to stay on top of them because a flaky test that gives you unreliable results is worse than worthless, is what I say. Worse than worthless is what I say. Because they will erode the confidence, not in just that one test that's failing, but in all of the tests in your program. If somebody sees, hey, your dashboard is always showing failures, but the product seems fine, what's up with that? There's really flaky tests erode confidence in your entire test suite. All right, let's talk about human-based tests. You get some experts, people who really are great at testing, can give you great feedback and find those landmines. Humans can judge the fitness for use. They can give you usability feedback. For fitness of use, I like to say they can tell you if you built the right product in addition to did you build it right. So there's a big difference between having the right product and a product that doesn't have bugs and doesn't crash, but might be useless. So you can get opinions from humans, and testers are full of opinions, I know. Localization. Yeah, we can do machine translations and we can say, yeah, this word means the same thing in that language. But often the exact translation is very context dependent. The word network we use for both a computer network and for a network of friends or a network of acquaintances or business network. Those are two totally different concepts in most other languages. Adaptable. So you don't have to give step-by-step instructions to a tester. You can tell them, hey, here's the user story. Tell me your opinion. We're going to try to find some bugs on this feature. And with very high-level guidance, a human tester can give you great results. And with the modern burstable testing like we have at Testlio, we have a network of 10,000 plus testers that are available 24/7 across the world. Now let's talk about some of the downsides with human testers. The outcomes of a human tester is very dependent on the skill of that individual tester. So it's why we have a high bar with who we accept, and we constantly maintain vigilance on their performance. And then also, with humans, you're going to get less throughput in terms of tests executed per unit of time than you would with machines. All right, last slide. I want to give you 3 tips for creating burstable tests. So the first is you want to create atomic tests. So atomic tests means you have a test case that is its own entity. You have your setup and teardown for each individual test. This is for an automated test because then that allows you to do is you don't have to run your tests in sequence. You can split them up and run them in parallel. So you can run multiple tests all in parallel. Now, it doesn't quite exactly translate to have a setup and teardown when you're talking about human tests. But if you have a test plan that says, let's say it takes 20 hours to execute, and you want to get 10 testers, let's say you give each tester 2 hours to execute. So you want that each tester to have like about a setup and teardown, and then about 2 hours worth of work to do from there. So you don't want to have one setup and one set of data entities that can only be used sequential for all 20 hours of testing. One thing that's very important is you need to pre-qualify your build before you distribute it. So, if you have a bad build and you distribute it to 20 machines or to 20 testers, you're going to waste 20 machine times or 20 testers times. So you really need to run your tests, automated smoke tests, to pre-validate that build before you distribute it. And then last tip is the benefit of having humans is to actually apply that creativity. So even if you do have step-by-step tests that you need your people to test, it's a great thing to also give them some latitude. What I like to do is if I have a 2 hours worth of work for a tester to do in terms of step-by-step test cases, I'll give them another 15 minutes to half an hour of exploratory testing and say, hey, go check these 3 things out using this time box. So that is my slides. I want to thank you. If you want to contact me, feel free. I'm john@testlio.com. I love to talk about testing strategy and will love to help you talk through your problems. We also have burstable testing in the SauceCon Slack, so we can continue the conversation there. And I'm going to stop the share, and hopefully we'll have some time for Q&A. Are there any tools available to decide where to do burstable testing? What do you mean by a tool to decide where to do burstable testing? I guess there's services out there like Sauce Labs is great to do burstable testing for automated tests because it makes it very easy to spin up a lot of machines. And then Testlio, my company, and we had their competitors to Testlio that are kind of in a crowdsourced space. But you have to be a little bit wary about those. Or some of the one thing you want to make sure is that the testers are actually going to collaborate together for your project and not compete with each other. So a lot of companies work on a bug bounty model, which is a great model if you want to seed your bug tracking system with a lot of bugs. But over time, you'll get a lot less value out of those bug bounty model type of places. And to do regular testing, it's good to have a team that's going to be working together and tell you what's working in addition to what's broken. What is meant by shift left philosophy? Sure. What shift left means to me is that you try to take all of your, in the old world, you would build a bunch of stuff and then you would test it. And that still does happen to some degree because you want to do a lot of regression tests and performance stuff like that when you have a completed product, acceptance testing for sure. What shift left means is you move earlier in the schedule. The right versus left is the schedule. So, schedule is usually earlier time on the left and later on the right. So you want to shift your testing and quality activities to the left in that timeline. Basically do them earlier. So I always like to say it's great if you're finding problems before the customer. It's even better if you find the problems earlier in your life cycle, like during the design time or requirements, and it's even better to prevent the problems from happening in the first place. So that's shift right mentality is like that. You want to shift your quality activities to the right in the timeline. And then what that in theory does is it's more efficient to fix the problems the closer you are to the source of the problem being created. And also you hope to have fewer problems overall by doing that. How do you get testers to follow the same path? Do you have a test case management standardized testing process against different applications? Yes, yeah, we do have a test case management system that's pretty comprehensive. And what that allows us to do is several things. One is we can create the tests, they're persistent, and then we can divide them up across many different testers. So, and then we can also run the same tests against different languages, people in different countries, and on different platforms. So our test case management system facilitates all of that. Okay, I think we are out of time. Oh, Jack just confirmed we are out of time. So yeah, please definitely, you can send me an email or collaborate on Slack. I'll be monitoring Slack for the rest of the afternoon. Thank you very much. Have a great day.